Fifth grade Excel, lesson 75. And this is going to be on recognizing parts of a circle, calculating the diameter given the radius, and associating the 360 degrees in a circle with 1/4, 1/2, 3/4, and full turns. And live in the studio audience today, we have Mr. Taylor.
Hi.
Oh, there's Taylor. Kaylee.
Hello.
And Emma's taking an AR quiz. Say hi, Emma.
Hi.
Okay. Here we go with the lesson. The center of a circle, point A, is the point that is an equal distance from any point on the circle. Points B, C, D, or E. So the center, right here, what you're being taught, has equal distance from any place on the circle. It's not closer to any part of that circle than any other part. That's called the center of the circle. Pretty tough, huh? A chord is a line segment connecting 2 points on the circumference. So this is a chord, and that's a chord. Anything where you have a straight line segment connecting any part of the circumference of the circle. And, oops, that's not what I meant to do. Let's clear that out. The distance from the center of the circle to any point on the circle is called the radius. So if I start here in the center and go to the outside edge, those are called radii, or each one is called a radius. Did you already know that, Taylor?
Yeah.
That's awesome. All right, a diameter is a straight line drawn from one side of the circle through the center to the other side. So the diameter of this circle goes from here all the way across. That's a diameter. This would be a diameter. This would be a diameter. Notice some kids get radius and diameter mixed up. It's kind of easy to remember the difference because the bigger word is the biggest line segment, is the bigger line segment. Smaller word, smaller line segment. All right, so if you know the diameter or the radius, you should be able to figure out the other piece. Let's say the radius of this circle is 2 inches. Well, if the radius is 2 inches, what would the diameter be, Taylor? Taylor, the radius is 2. What would the diameter be?
I have no idea. 4.
Oh, 4. Okay. Needed help from Kaylee on that one. The other radius is 2, so we have a total of 4 centimeters all the way across. And they give you a problem like that down here. It says if the radius of a circle is 3 inches long, what is the diameter of the circle?
6.
So if the radius is 3, this other radius is 3 also, the total is 6. What was the label on that one? 6 inches. All right, hopefully that's simple for you. You might want to go back and review this part again. And those terms are located in your glossary, so if you forget what they are, use your glossary to help yourself. The distance around the circle is called the circumference. All the way around here, the circumference. The circumference is about 3 times the length of the diameter. If I take this piece right here and move it out on the edge, 1 time, 2 times, 3 times, it's about 3 times the distance plus a little bit of extra compared to the diameter. An arc is a continuous section of the circumference. So this would be an arc right here. This would be an arc. This would be an arc. Any place, any little chunk of the circumference is called an arc. Points A, F, and G are inside the circle. Here's G, here's A, here's F. Those are all inside the circle. Points H and J are outside the circle. And B, C, D, and E are all on the circle around here. Now let me get this mess out of the way. And I'm going to have you do this next part down here. Using this circle right here, this diagram, you need to identify one of each one of these. You do not need to identify all of them, only just one example of each. Pause the video while you're working on that. Turn it back on when you're ready to see the solution. All right. A radius. Kaylee, can you name a radius?
E to H.
E to H. That is one radius. And you need to write it with capital letters because they have capital letters down here, and you need to put a line segment symbol on the top of that to show that it is a segment. Now there are 3 other correct answers for this one. You could also put HE for that same segment. What are the 3 other ones? This one would be what? GE, like the light bulbs, right? or EG. And then this one would be CE. Kaylee's got this. And then the last one would be Ed. Okay, now you didn't have to write all 4 of those, only one of those, and you can reverse the letters like that and still have it correct. But those are the 4 possible answers. Okay, only one possible answer for the second one, the center. What's the center of the circle, everybody?
E.
Good, Taylor got it too. And give me a diameter. Taylor, can you name a diameter of the circle?
I do not know the diameter. Oh, G.
Where's the diameter? Goes from G to what?
E.
To what?
E.
G to E? That's the radius. G to
C.
C? No, that would be an arc.
I don't know this
G to
stuff.
D.
G to D would be a diameter.
Oh.
Don't forget the segment sign on the top. There's one other diameter. Do you know what it is, Taylor? G to D.
W.
W is not correct. C and H, pure cane sugar. There it is. Okay. CH. Now again, you only had to write one of those, but those are the 2 possible answers. A point on the circle. I see 5 possible right answers for that one. Can you name a point on? Taylor, this is easy. Name a point on the circle. Come on, you can do it. He's busy coloring. Okay, what are you coloring right now?
The Joker.
It's a joker. He's coloring a joker, so he's not interested in the points on the circle.
Okay, fine.
P. What did you just say, Kaylee? P? You can't say that. Okay, so we got P. What else?
C.
G, C,
D.
D, and H. You could name any of those. You didn't have to name all of them. A point inside the circle. 2 possible answers for that are?
A.
And?
E.
E. Good. A chord. Can you name a chord? Remember what a chord is?
I don't, because I never learned it.
The way I remember it is it's kind of like the circle is a guitar, and the strings make a chord sound on it. So you'd have strings that go
C, D, C,
C to D would be a chord. Excellent. Okay, that would be one possible answer. Are there any other chords?
G to H.
Good. G to H. And any other chords? Well, diameters are also chords. So G to D, because it does connect one part of the circle to another, and C to H is also considered to be a chord. So any of those 4 could be right answer. How about an arc? Can you name an arc? Good. From P to H is an arc. And you have to put this symbol over the top to show that it's an arc. Otherwise, you could name GH as an arc, but if you have a curve over the top of GH, you're talking about the arc GH. If you have a straight line over GH, you're talking about the chord for GH. Emma's back. Did you pass, Emma?
Yeah.
Awesome. How many points did you get?
14.
14 points! She's a reading machine. Okay, there are many other arcs on this. You could do C to D with a curve over the top, C to G, D to H. You could even do D to C around that way, whatever. So any of those will work as long as the 2 points are on the circle. Okay, now we're going to calculate some radii and diameter. If the radius of a circle is 6 feet, the diameter will be, well, if the radius, that's that part here, is 6, then all the way across is going to be
12.
12. Yeah, of course, 12 feet. You just do 6 times 2 to get that, or 6 plus 6. Go ahead and try number 2. Pause the video, turn it back on when you're ready for the answer. Diameter of a circle is 8. What is the radius? Now, if you put 16, you did it backwards, because 8 is the diameter all the way across. So what would each radius be? 4, right? Because you're going to divide this radius by 2. So the answer is 4 centimeters. All right, let's move on. Now we're talking about how many degrees there are in a turn. If we take, say, a hand like on a clock and turn it around a quarter of the way around the circle, an angle is formed right here. What kind of an angle is that? Right angle, good. And how many degrees is a right angle? 90 degrees. So we'd say a 1/4 turn, 1/4 of a turn around a circle makes a right angle or a 90-degree angle. If I take this hand and turn it around halfway on the clock and call it a half turn, how many degrees is that?
50.
50?
180.
180. Good, because we have a 90 here and we have a 90 here. 90 and 90 is 180. What about a 3/4 turn?
53.
What would that be? 270, right? And then a full turn. You start here, you go all the way around. What's that? 360. Just like when you're on your skateboard and you flip your skateboard all the way around, it's called a 360. Okay, looking at the model shown above, what kind of angle is formed when there's a 1/4 turn? We just told you the answer to that. What is it?
Right angle.
Right angle. Good. And how many degrees are there in a 1/4 turn, everybody? 90 degrees. All right, let's move on to our last page. Go ahead and solve all these, 3 through 6. Pause the video when you're ready to see the answers. All right, let's shout out the answers. Ready, Tay? You're going to shout out the answers? How many degrees are there in a 1/2 turn, everybody? 180 degrees.
493.
Oh, almost. How many degrees are there in 3/4 turn?
270.
Good, 270. Boy, my pen's being all weird on me here.
Easy here.
How many degrees are there in a full turn?
360.
360. And what is the sum of the central angles of a circle? In other words, we have a circle and we add up all the angles in the middle.
90.
We add all these angles together. What are you going to get?
90.
360. It's the same as this one. Because, look, it doesn't matter how you slice it up. It's still going to be 360 all the way around when you add all those angles together. All right, well, thanks for watching. Have a good day.